12.3, magnetism. So, what is magnetism? Magnetism, first off, properties of magnetisms. Magnets have what's called magnetic fields. This is what causes them to have forces on other magnetic materials. Okay, every magnet has a north pole and a south pole. So this is showing you a bar magnet here. So you have a north and a south, and these lines coming out of it, these are called your magnetic field lines. This is what's causing the attraction between your different poles here. This, we have iron filings, and as you can see, it's got this pattern going on here. This pattern is visually showing you your magnetic field lines, and this is that attraction between them. Okay, so you need to know a little bit more about the magnetic field lines. They always travel from the North Pole to the South, so it's always north to the South Pole. They are always strongest at the actual poles, so that's why you always see the lines coming out of the north going into the south, and majority of the lines are going to come from here, and they're going to slowly get smaller, more space between as you go towards the center of the magnet. Okay, so north to south, and they're strongest at the actual poles. Same as electricity, opposites attract, likes repel. What does that mean? Your north poles are attracted to your south pole. So if you get this scenario here, it's going to be north and north, so they do not attract. South to south, do not attract. North to south, they do attract. Just like electricity. Okay, the next few slides, you're going to have to draw in your notes, because you need to be able to draw them, or not necessarily draw them because the exam is multiple choice, but you've got to be able to pick out the correct drawing for the magnets given to you. So remember, if you have just one single magnet, it's always going to go from out of the north to the south, out of the north to the south, north, south, north, south, and then you're going to have some that are going to go all the way around and come back in like that. Okay, so that's if you have a single bar magnet. It comes out of the north to the south. So a single bar magnet is actually attracted to itself. It's just not going to bend because the material doesn't allow it to do that. This is called a horseshoe magnet. Same thing's going to happen. You have a north end and a south end. So again, from the north to the south. North, south, north, south. And then you are going to have some that are going to go all the way around it and come back like that. Okay. Now, the next three scenarios are if you have two magnets. So these are two different magnets. So you have a north end here, south, south, north. Okay. Not really interested in the outsides of the magnets, only the ones that are facing each other that you're going to have to be able to point out the correct electric field lines. So again, we have a north and a south. So it's going to go directly from the north to the south. North, south, north, south, just like that. This is showing you, visually showing you that opposites attract, because that the magnetic field line is going straight from the north to the south, showing that they're going to pull together because of that. Here, you have a north and a north. So what's going to happen is, okay, you get this magnetic field line. It wants to go this way, but the problem is you got another north. So it's actually going to curve away and go towards its other side of the magnet. So it curves, just like this one, out of the north towards the south, and the only south around is the south on the magnet it is. Same thing here. You have an S and an S. The only magnetic field lines coming from anywhere is from the other side of the magnet. So what's happening is you end up getting this. And because of that, these are not attracted to each other. Okay? Out of the north to the south. The only way they're attracted is if you have north and south like that. Okay. Magnetic domains is are areas of aligned polarity. What does that mean? Meaning polarity is your north and your south. Polarity means poles, so you have a north pole and a south pole. And to be aligned means they're all in the same direction. So this means if you have a magnet, if you have little pieces inside of that magnet, they have to be all within the same direction. So right now you see this one here, all the arrows are pointing in random different directions. This is unmagnetized because they're in so many different directions. The only way you can get this object to be magnetic is to take a permanent magnet and line all those individual domains up so they're all pointing in that same direction. Okay, and it would be going this way because that north is there. Okay, so if another magnetic field exerts a force on domains, the domains will line up, creating a magnet. And this only works in materials that have magnetic properties. Most important thing on here is that in a magnetic domain, they have to be aligned in order to be magnetic. Okay. Last topic here is an electromagnet. And it's exactly that. It's a magnet caused by electricity. So for example, you have a circuit here. The electricity is running through, and there's an iron nail, and that electricity is running through that iron nail because iron is a good conductor, so it's running through it. And you see these coils here? What's happening is the current travels through the coil and it produces a magnetic field. This is what's called an electromagnet. So what would happen is when you take this and you complete the circuit, this nail will become a magnet caused by the electricity going through it. One of the things you have to be able to do for me is tell me how to increase the strength of an electromagnet. The way to do this is to increase more coils. The coils are this piece right here. So it's the number of times this wire is wrapped around that iron nail. The more times it's wrapped, the stronger the field, the stronger the magnet.